We shall be learning the limits of logarithmic functions, but before that, we need to understand logarithmic functions first. So if we have f of x is equal to logarithm of x to the base a, then how do we understand the properties of this logarithm? First, we need to know x here. X here must be greater than 0, while a should not be 1, but a should be between 1 and 0 and greater than 1. So it means to say the value of a should not be negative, should not be 1. Okay, so that is between 0 and 1, or any number greater than 1. The first property of logarithm is the product. Logarithm of the product of xy to the base a is equal to, you're going to separate the two factors x and y. So as you can see here, this is x and y. Then you're going to copy base a and you're going to separate them using the operation addition. So it means to say, whenever you see a product, or whenever you encounter a product of a number, let's say for example logarithm of 2x, and that is a product of 2 and x to the base 4, then you're going to separate the factors 2 and x. Now copy base 4, the other is also base 4, to be separated by the operation addition. Another, if you have logarithm of, let's say, wz to the base 2, then you're going to separate logarithm of w base 2, logarithm of z base 2, then add them. Okay, another clarification, you might as well do this. Let's say you have logarithm of x plus y base 2, and then you will have, you might say that is equal to logarithm of x base 2 plus logarithm of y base 2, and that is actually wrong, because if you will observe x, y here, that is not a product of x and y, that is a sum of x and y, and you cannot follow the rule of product because as you can see, that is x plus y, not xy. Okay, in the quotient rule, you can see a quotient of x and y with a base a here, so you can separate it using subtraction, but take note the numerator x here must be written first, and that is positive, and the denominator will be separated, will be the negative. That's why we have subtraction sign here. So let's say for example you're going to expand logarithm of 2 over 3 to the base 3. For example, you have the numerator is 2, the denominator is 3, then have the same base logarithm of 3. Now separate them using subtraction. Another, you have logarithm of a over b to the base, let's say base f. Then you have to write first logarithm of a base f, because a is the numerator, so logarithm of b base f here to be written as the second term. Clarification here, you will not do this because it is considered to be erroneous. No, it does not follow the rule. Let's say logarithm of x divided by logarithm of y, and you might think that is equal to logarithm of x minus logarithm of y. Well, it's not the same, because as you can see, that is a quotient of two logarithms. Okay, but in here, a quotient of a number x over y. So you just need to be very careful and always observe the proper property. On the next property, the power, or the power rule for logarithm, that is logarithm of x raised to n to the base a, then you are going to bring down n, and that will be multiplied to logarithm of x base a. Now, common mistake that you might think that you need to erase in your mind. Let's say, for example, logarithm of x to the base 2, the quantity raised to 2, is not equal to 2 times logarithm of x to the base 2. Why? Because the presence of the parenthesis tells you that you're going to square the quantity logarithm of x base 2. However, if it was written this way, logarithm of x squared to the base 2, and that is the time that you need to follow the rule. Bring down 2, so you have 2 times logarithm of x to the base 2. So another, let's say, logarithm of 2x, the quantity raised to 3 base 5, can actually be written into 3 times logarithm of 2x base 5. That is the power rule. The change of base rule is necessary in understanding logarithm because it is in this manner that you are going to manipulate the number and the base. So as observed here, you have b as the number and the base a. Then you're going to have a quotient of two logarithms. So expressing b as logarithm of b and a as a logarithm of a, and highlighted here is letter C, meaning if you're going to expand it using the change of base rule, you need to have the same base. So let's say, for example, you're going to expand using the change of base rule. Logarithm of 5 base 3 can be written into copy 5, logarithm of 5 over logarithm of 3. So you see, 5 is being written here on the numerator while 3 is being written on the denominator with the base 10. So remember, when the base is 10, that is already common logarithm, so you don't need to write. That can also be written into ln of 5 over ln of 3, ln or natural logarithm. It means that the base is e. Okay, you can also have logarithm of 5 base 6 over logarithm of 3 base 6. Well, all of these are the same. So that is how we are going to use change of base in understanding some of the rules of logarithm. So before we evaluate the limits of logarithmic functions, we need to emphasize the domain of these functions. Remember that in the domain of this logarithmic function, it is clear that when the number is already part of the domain, then you can immediately do direct substitution. However, when the number is considered to be the critical number or the least or the maximum number, then that's the time for you to understand that it might happen that the limit of the function as x approaches to that critical number does not exist. So we're going to find the domain of the following functions by first getting to know the rule that the number x minus 1 should not be a negative number and should not be 0. Therefore, you need to get x minus 1, and that must be greater than 0. So move negative 1 on the other side, you have x is greater than 0. So it means to say domain of this function must be all numbers. It must be all numbers greater than 1. Okay? You cannot use 1 in this case. You cannot use 1 because 1 minus 1 will give you 0, and there is no logarithm of 0. Okay, now let's move to the second example. Logarithm of 5 minus x to the base 5. Get 5 minus x. Equate that to, or let that be greater than 0. So it means to say, okay, lipat natin na negative x, that will become x. So this is 5. So when 5 is greater than x, then x must be less than 5. So the domain of this function will be the set of all real numbers less than 5. Okay, let's have a check, a proof of this. Let's say 5 minus 5 is 0, so you cannot use 5. But if you use 4, 5 minus 4 is 1, so that is accepted. Gamit ka ng 3, which is less than 5. 5 minus 3 is 2. Accepted. So, ibig sabihin, lahat ng numbers na mas maliit sa 5 ang pwedeng gamitin. Okay, let's move to the next. Logarithm of x squared is equal to 4. Now, in this case, you are guided by the power rule. Pwede daw natin i-rewrite ito at magiging 2 times logarithm of x base 4 after bringing down 2 here for us to be guided on the number x. Dito, ang number x na ito must not be a negative number and should not be 0 at the same time. So, ang x na yan must be greater than 0 or that is in interval notation. So, pwede ka na magkaroon ng logarithm of 2, logarithm of 3, logarithm of 4, logarithm of 1/2, pero hindi ka pwede magkaroon ng x that is 0 and a negative number. Okay? Now, on the last example, logarithm or natural logarithm, ln of x squared plus 1. As you can see, that is x squared plus 1, you cannot transform that. That is not equal to ln of x squared plus 1 or ln of x squared plus 1. That is not true because x squared plus 1 that is not a product. Okay? So, ibig sabihin, we need to understand at the same time the behavior of x squared because x squared can take or x can take any number, be it positive, negative, or 0, because squaring it will give you still positive. Therefore, and you're going to add that to 1, so meaning positive plus positive is always positive. And that's what you need in natural logarithm. Hindi pwede magkaroon ng negative. At dahil naka-square yan, you can now enjoy all real numbers as a domain. It means that this x squared, you can have negative 2 square negative 2, and that is 4. Then all negative numbers are now accepted in this case. So after having the properties of logarithm, let's now talk about the different rules, or should I say the different shortcuts in evaluating the logarithm. Well, first of them is the logarithm of a to the base a is equal to 1. And the proof of that is, let's say for example, we don't know that that is equal to 1. So let that be x mean time. So from this form, we're going to rewrite it in exponential form. So we have a raised to x will now be equal to a. And since we have the same base, then they must have the same exponent. Then this must be 1. Therefore, x is equal to 1. So it means to say the rule now tells us that logarithm of a base a must always be equal to 1. That is why if we have logarithm of 5 base 5, that is simply 1. Logarithm of 10, that is 1 because the base is 10. Common logarithm. You can have logarithm of 11 base 11 is also equal to 1. Now from this rule, we can now have ln of e is equal to 1. That is a natural logarithm, which is originally written into this way, logarithm of e base e. But according to the mathematician, then that must be written into ln of e, and that is equal to 1. Originally, logarithm of e base e. Okay, now let's move to the second rule. Logarithm of a raised to x base a is equal to x. So how did it happen? Ibalik natin sa form niya in exponential form. This is base a, so I have a x, the exponent, so a raised to x is equal to a raised to x, kasi this will now be the number here. So as you can see, x is equal to x. Sa madaling salita, whenever we encounter base and the base of an exponential number are the same, then the exponent will be the answer. So just like this, if you have logarithm of 2 raised to 4 base 2, 2 and 2 the same, the answer is 4. Logarithm of 5 base 5, well, let's say for example 5 raised to 3, then the answer is 3. But take note that the common mistake will be logarithm of 5 base 5 raised to 3 is not equal to 3. Why? Because logarithm of 5 base 5 is actually equal to 1. 1 raised to 3 is 1. So you need to be very careful, okay? Now just merely observe the rule and be guided by the order of these variables. The next will be a raised to logarithm of x base a is x. You see, they have the same base. Ang nakikita natin ay naka-express in exponential. So kapag i-rewrite mo yan, let's say, let x be equal to y. Let's say, we don't know yet that that is x. So mangyayari, i-rewrite mo yan into logarithm as a proof. Gagayahin mo ang base a, and this will be y, is equal to the exponent logarithm x base a. And as you observe, x is equal to y, and according to the rule of logarithmic equation, if x is equal to y, then y is equal to x. So sa madaling salita, itong x na to, yun daw ang magiging sagot in the evaluation. So for the example, if you have 3 raised to logarithm of 5 base 3, then 5 ang sagot. Okay? Another 10 raised to logarithm of, let's say, logarithm of 10. The answer is 10. Because this is also 10, common logarithm. You can also have e raised to ln of x. You see, natural logarithm is also base e, and the exponential is base e. The answer must be x. That is another rule, okay, which is generated from the general rule a raised to logarithm of x base a is equal to x. From these general rules, we can now have the rules of the natural logarithm. Okay, from the natural logarithm rules, i-generate natin sila. So logarithm of a base a equals 1 is also equal to ln of e equals 1. Okay, because ln of e is also base e, at nagkataon pa na ln of e ang tinanong, and that is equal to 1. And in here, this can be ln of e raised to x. That is also equal to x. Okay, then last, this is also a raised to, that must be e. E raised to ln of x is equal to x. So let's have an example here. Let's say, for example, you have ln of e raised to 2, then the answer is 2, because if you're going to follow also the power rule, you can bring down 2 here. So you have 2 ln of e, and since ln of e is simply 1, then 2 times 1 is 2. On the third rule, let's say you have e raised to ln of 2, the answer is simply 2. Okay, or you have e raised to ln of e, the answer is e. Just to follow the rule, because x must be x here. The easiest rule is logarithm of 1 to any base a is 0. Okay, so if you have ln of 1, that is also 0. Another logarithm of 1 to base 1/2 is 0. Logarithm of 1 to the base 5 is also equal to 0. Basta pag napansin natin that that is a logarithm of 1, regardless kung ano ang base, that is always equal to 0. Now let's move to the limits of logarithmic functions. This is done by direct substitution only. Okay, so limits of logarithm of x to the base 3 as x approaches 3 is equal to logarithm of 3 base 3, and you see they have the same base and a number 3. The answer is 1. limits of logarithm of x to the base 3 as x approaches 9 is equal to logarithm of 9 to the base 3, direct substitution. And since 3 raised to 2 is equal to 9, then logarithm of 9 base 2 is equal to, base 3 is equal to 2. Limits of logarithm of x plus 1 to the base 5 as x approaches 24 becomes logarithm of 24 plus 1 to the base 5 is equal to logarithm of 24 plus 1 is 25 to the base 5. And since 5 raised to 2 is equal to 25, then the limit problem is equal to 2, the exponent, because logarithm is exponent at the same time. Limit of logarithm of x plus 1 to the base 1/2 as x approaches 15 is equal to logarithm of 15 plus 1 to the base 1/2 is logarithm of 16 to the base 1/2. And since 1/2, the quantity raised to negative 4 is equal to 16, so the answer here is negative 4. In this case, limit of ln of 4 as x approaches 3, ln of 4 is a constant. This one is constant, so the answer according to the constant rule remains to be the number itself, no? ln of 4. Next, ln of e raised to x as x approaches 2 is equal to ln of e raised to 2, and the power rule can also be 2 times ln of e, where ln of e is 1, so 2 times 1, the answer is 2. Another example, ln of 3 raised to x as x approaches negative 2 becomes ln of 3 raised to negative 2. So negative 2 can be brought down according to the power rule. You can have negative 2 times ln of 3. That can be your final answer. The last example, limit of logarithm of 5 raised to x plus 1 as x approaches 2 is also equal to logarithm of 5 raised to 2 plus 1, and that will be logarithm of 5 raised to 3 is equal to, bring down 3, we have 3 times logarithm of 5, which can also be written into logarithm of 125, because 5 raised to 3 is equal to 125. So you will enter answer in logarithmic form because you cannot approximate it. That is already the exact answer. Okay? Isa na siyang constant. So another limit of ln of x as x approaches 7 is simply ln of 7. Limit of logarithm of x plus 7 as x approaches 2 is logarithm of 2. Let x be equal to 2. Substitute. The answer is logarithm of 9. Here, limit of ln of 3 raised to x as x approaches 2 is ln of 3 raised to 2, which can also be 2 times ln of 3. Or that is also equal to ln of 9, because 3 raised to 2 is 9. Limit of logarithm of 5 raised to x minus 1 as x approaches 2 is equal to logarithm of 5 raised to 2 minus 1 is equal to logarithm of 5, because 2 minus 1 is 1 and 5 raised to 1 is 5. Logarithm of 5. On these examples, meron nang naka-attach na mga constants. Okay, so you are just going to multiply these constants to the limit of the given logarithm. So let's have number 1. This is also equal to negative 3 times ln of e raised to 7. And since ln of e raised to 7 follows the rule of ln of e raised to x is equal to x, so this will be negative 3 times 7. And the answer is negative 21. Next, we have logarithm of negative. Okay, that is negative logarithm of x plus 7 is equal to negative logarithm of, let x be equal to 93, so 93 plus 7 and that will be negative logarithm of 100. And since 10 raised to 2 is equal to 100, the answer is equal to negative 2. Substitute 4 times ln of 3 raised to, let x be equal to 2. So you have 2 here. So 4 times, okay, you can bring down 2 and you have ln of 3 by the power rule. Pwede bumaba ang 2 dito. 4 times 2 is 8. So 8 ln of 3 is the final answer. Next, you have limit of 1/3 logarithm of x plus 120 to the base 11 as x approaches 1 is equal to 1/3 logarithm of 11. Let x be equal to 1, so 1 plus 120 is equal to 1/3 logarithm of 121 to the base 11. And since 11 raised to 2 is equal to 121, then logarithm of 121 to the base 11 is equal to 2. So that will be 1/3 times 2. The answer is 2/3. Okay, so one question that might come or you might think is, when will the logarithm, the limit of the logarithm does not exist? So kailan siya hindi nag-exist? The clue here is you need to observe first the critical number. Remember that x plus 7 should not be 0 and should not be a negative number. Kaya alamin mo yung critical number. Saan ba siya nagiging critical? X is greater than 7. This negative 7 becomes the critical number. Sa madaling salita, hindi mo kasi makikita ang graph ng function sa left. Wala na siyang graph ang logarithmic function on the left, negative 7. Pero may graph on the right of negative 7. So it means to say left does not exist, even if right exists. Okay? At dahil hindi sila pantay at hindi sila equal, sa madaling salita, the two-sided limit which is given, its limit does not exist anymore because the left and right, one does not exist while the other may have a limit. Okay? So considering the rule na dapat yung magkabilaan ay mag-exist. So here, x plus 1 must be greater than 0. X must be greater than negative 1 para hindi siya negative or 0. So itong negative 1 is 0 niya ang x plus 1. Kaya gagamitin mo lahat ng numbers na mas malaki sa negative 1. So negative 1 acts as the critical number. On the given, x approaches negative 1 which is two-sided. So kung two-sided limit yan, ang left hindi nag-exist tapos ang right nag-exist. Then according to the condition, left and right must exist and must be equal. And since one of them does not exist, then the limit of the two-sided function or the two-sided limit does not exist in this case. Another, you have 2x minus 4, and remember 2 is being used and that is a two-sided limit, and 2 times 2 is equal to 4, so 4 minus 4 becomes 0, where 0 should not be the result. Okay, therefore left of 2 versus right of 2, left of 2 does not exist, right of 2 may exist, at dahil may isa na hindi nag-exist, then the two-sided limit will not exist also. Okay, so you need to observe left and right. Basta kapag logarithmic function, when left does not exist and right does not exist, or when the value of c is the critical value, then the limit, the two-sided limit, will not exist. Now, how do we simplify this given? Take note that we need to make use of the different rules for us to have a faster way of evaluating the function. So the first limit of ln of x as x approaches e raised to x, we can now substitute e raised to x, and that is ln of e raised to 2 plus, okay, limit of logarithm of 10 raised to x as x approaches 2, and that will be logarithm of 10 raised to 2 minus limit of logarithm of x plus 1 to the base 4 as x approaches 15 is logarithm of 15 plus 1 to the base 4. Now moving to the simplified answer, limit of ln of e raised to 2 is actually equal to 2 by the rule, power rule, at the same time the rule of ln of e raised to x is equal to x. So yung exponent na 2, yun na yung final answer niya. That is also true in logarithm of 10 raised to 2 to the base 10 because 10 and 10 the same and 2 can just be brought down, and logarithm of a base a is equal to 1, so it follows logarithm of a, or logarithm of 10 base 10 is 1, 1 times 2 is 2, or simply copy the exponent. This one, 15 plus 1 is 16, so you have logarithm of 16 base 4. 4 raised to 2 is equal to 16, so the answer is 2. Logarithm of 16 base 4 is 2 because 4 raised to 2 is 16. So 2 plus 2 minus 2, the answer is 2. That is a simplified limit. Okay. Next, you have 2 times limit of logarithm of 10 raised to x as x approaches negative 1, and that will be 2 times logarithm of 10 raised to negative 1 divided by negative 3, limit of x minus 2 to the base 7 as x approaches 9 is equal to negative 3 times logarithm of 9 minus 2 to the base 7, and logarithm of 10 raised to negative 1 base 10 is equal to negative 1 to the, according to the rule of, okay, logarithm of a raised to x base a is equal to x. So copy lang daw yung exponent. So 2 times negative 1 divided by negative 3 times 9 minus 2 is equal to 7. So logarithm of 7 base 7 is equal to 1. So you now have negative 3 times 1. Now the answer here is positive 2 over 3 because 2 times negative 1 is already negative 2 divided by negative 3 is 2 over 3. So as you observe, we are making use of the different rules. So you need to observe the different rules for you to have a faster and easier evaluation of limits.